Hello, dear lovely students. So this is me again, م.ئەحمەد at the private Zhyar in the basic school. So today we have a new subject. It is chapter 4, section 7, experimental probability, page 162. So first, experimental probability is a probability that is determined on the basis of a series of what? Of experiment. So if you want to, let's explain more, a random experiment is done and it is repeated. Okay, it is repeated many times. So to determine their likelihood, and each repetition is known as trial. Okay, then the experiment is conducted to find the chance of an event to occur or not to occur. So the rule of experiment probability is number of times the event occur. It means appear. Okay, over what? Total number of trials. Total number of trial. Again, the number of times of event appear over total number of trials. So if you explained with an example, it says after 1,000 spins of the spinner, we have a spinner here, okay, the following information was recorded, estimated the probability of the spinner landing on red, As you see, we have three colors. We have yellow, we have red, and also we have blue. But we want to find the probability of the spinner landing on red. Then we have the schedule. Okay, we have the information here. The outcomes are blue, red, and yellow. So when we spin the spinner 1,000 times, then for the blue we have 448, for the red we have 267, for the yellow we have 285. Then we want to find the probability of the spinner landing on red. So first of all, write P of red is equal, then look at the schedule, look at the table. Then we have blue, red, and yellow. This is red. So for red, we have 267. 267. On the denominator, write 267. What about the denominator? In numerator, we wrote 267. What about denominator? All the trials, we said that it is 1,000. 1,000 spins. So this is the result, 267 over 1,000. If you want to write the answer as a decimal, it's going to be 0.267. This is the answer as decimal. And if you want to write the answer as a percent, it's going to be 26.7%. So the probability of the spinner landing on red, it is 26.7%. If you want to find the other colors, for example, you want to find the probability of blue. P of blue, it's going to be 448 divided by 1,000. Okay, then it's going to be 0.448. This is the result as a decimal. As a percent, it's going to be 44.8%. And also for yellow, it's going to be 28.5%. This is the probability of the spinner landing on red, on, let's say, blue, and also on yellow. Then the next example, example B, a marble randomly drawn out of a bag and then replaced. The table shows, this table shows the results after 100 draws. Then estimate the probability of drawing a yellow marble. So look at the colors. We have green, red, yellow, blue, and also we have white. It says find the probability Okay, estimate the probability of drawing a yellow. So P of yellow is equal. So yellow is 21. Then 21 out of 100. So divided by 100. 21 divided by 100, it's going to be 0.21 as a decimal. As a percent, it's going to be 21%. So the probability of drawing a yellow marble, it is 21%. If you want to find the others, for example, if you want to find green, it's going to be P of green is equal 12 over 100, 0.12, then it's going to be 12%, and so on for the other colors. Then we have example C. It says Grégoire has been observing the types of vehicles pass through an intersection. He obtained the following information: estimate the probability that the next vehicle through the intersection will be an SUV. So we have the table. The outcomes are, let's say this is the type of the cars. We have sedan, truck, and also SUV. We want to find the probability of SUV. P of SUV is equal. So the number of the SUV is 12. So write down 12. Okay. Then in the denominator, we are going to write the total. Okay, we have 29, then plus 9, also plus 12, and it's going to be 50. So the total of the cars is 50. Then it's going to be 50, 12 over 50. After you simplify it, it's going to be divided by 2. It's going to be 6 divided by 2 is going to be 25. So 6 over 25. Then this is the result as a fraction. If you want to write the result as a decimal, it's going to be 0.24 and it's going to be 24%. Maybe some of you asked the question that what did we get 0.24? It's quite simple and easy. We are going to do the long division. 6 divided by 25, okay? Or you are going to say how to make 100 here. Multiplied by 4, it's going to be 100 multiplied by 4. So it's going to be 24 over 100. So 24 over 100, it is 24%. Even if you want to find the others, for truck, it's going to be 9 over 25. For sedan, it's going to be 29 over, it is 50. 29 over 50. So for the others, you can find it so easily. So right now we have a question that says, a ball randomly drawn in a bag, then replaced. The table shows the results after 100 draws. What is the probability of drawing a blue ball? So we have the table. It is, the outcomes are blue, green, and yellow. Then also we have the results. For the blue we have 27, for green we have 53, and yellow it is 20. Then we want to find the probability of what? It says what is the probability of drawing a blue ball? A blue. So write down blue. Equal. So for the blue color we have 27. So write down 27. Then what is the total? The total is, it says 100. 100. So write down 100. This is the result as a fraction. But if you look at the answers, we don't have 27 over 100. We have to change it to, or convert it to decimal. It's going to be 0.27. It means 27%. So the correct answer is B. 0.27. So dear lovely students, this is all about the experimental probability. I hope you're all doing great. So thank you so much.